Let's talk about factoring this quadratic expression we have right here using the AC method. When we're using the AC method, what we first do is multiply the lead coefficient and the constant coefficient together. That is our A times our C in the AC method. So I get that 3 times negative 28 here is negative 84. What we're looking to do now is find two numbers that multiply to be negative 84, but add to be 17. How I start this process is I'm going to create a factor tree for all the numbers that multiply to be 84. One thing that I can do when I do this, I can use the prime factorization to 84. If you've never used that before, I'm just going to do a real quick rundown of that. I'm going to take 84 and I'm going to split it up as a multiplication. In this case, I know 84 because of what I just did is 3 times 28. Then what I'm going to do is break up these composite numbers, the numbers that aren't prime. So write this as 3 times 4 times 7. The only composite number here is the 4 is 3 times 2 times 2 times 7. Why this is helpful is that any pairing of numbers that multiply to be 84 have to be a combination of these primes. I'll just show you quickly how I do that. So first I start with a 1 and an 84, and then it's 2 times, well, I get 2 here. It's going to be 2 times whatever the rest of this stuff multiplies to be. So it's 2 times 3 times 7 is 21, times 2 is 42. And then 3, well, I know it's 3 times 28. I already have in that. 4, well, 4 times, in this case, this is a 4. 4 times 21 must be 84. And then 5 doesn't go into it. 6 does. 6 goes into 84 because 3 times 2 is 6. It's 6 times 14. And then 7 obviously goes into it. It is 7 times 12. 8 doesn't go into 84. 9, 10, 11, and then 12. The next number I would check is 12, but I already have 12 on this side. This is a fast way of making all of the factor pairs that multiply to be 84. Once I have my factor pairs, I now realize that I need it to be a negative 84. I want it to be a negative 84, so one of these numbers must be negative, but also I want the addition of those numbers to be positive. So I'm going to give the negative to the smaller of these numbers. Now I know all of these pairs multiply to be a negative 84. The question of which of these pairs add to be a positive 17. After a quick check of adding these all together, I see that negative 4 plus 21 is a 17. What I do with that factor pair is I'm going to set up a factor by grouping by splitting up this middle term here. I'm going to write 17w as a 21w minus 4w. Two things to note here. First is it does not matter which order I write these. I actually could instead write this as a 3w squared minus 4w plus 21w minus 28. In fact, when you're doing this, the factor by grouping might be easier if you swap those middle terms. Second thing to note is that I haven't changed anything. All I'm doing is splitting up this middle term into two terms that are equivalent to it. The next thing I'm going to do is factor by grouping, which means I'm going to take these as two separate groups and factor out the greatest common factor. In this first group, I'm going to factor out just a w. And that will give me a 3w minus 4. In this second group, I'm going to factor out a 7, positive 7 importantly, and leaving me with 3w minus 4. Again, when I do factor by grouping, it's always very important that these binomial factors are exactly the same. I'm now going to factor out this 3w minus 4 out of these two terms. What I'm left in this term, if I take out 3w, is just this w. And then in this case, when I take out the 3w, I'm left with just a plus 7. And this is the final factored form of the quadratic above.